Hi everyone, welcome back to the course manufacturing process. In this part, we are going to discuss about the manufacturing operations which are not performed on presses. The important processes which are not performed on presses, either hydraulic press or mechanical press, are stretch forming, roll bending, spinning, and high energy rate forming processes. So let us study one by one. Let us start with stretch forming. In stretch forming process, the sheet metal undergoes stretching as well as bending simultaneously. So the material is stretched, and at the same time, the material undergoes compression. The material undergoes bending with the help of a die as shown here. So this process is called a stretch forming process. This is before stretch forming, and this is after stretch forming. You can see here the material bends. So it is exactly like a bending process, but before bending takes place, the material is stretched. So it is a combined effect of stretching, like tensile force is applied, and bending with the help of a die, and a particular and the shape can be produced like this. So typical application include curved panels such as car door panels or wing panels on aircraft, etc. can be made by stretch forming. So we are interested in calculating the force in stretch forming process, which is area times stress. Area acting is equal to L times T. L is the length of the sheet, and T is the stock thickness, instantaneous stock thickness, and YF is the flow stress acting on the material, which is K epsilon raised to N over 1 plus N. So die force can be determined by balancing vertical force component. So this is the force acting in a stretch forming process. Now, the next process is a roll bending process. In roll bending process, three rollers are used, as you could see here, three rollers. The upper roll applies a downward force, and it is supported by the two rolls on the other side. They rotate in opposite directions. So it is similar to a bending operations, and we use rollers for that. So upper roll, the necessary force or compressive force is exerted by the upper roll, and hence the material bends. It is basically used if a material or metal sheet panel is to be given a larger smooth radius. If we want to get a smooth radius, we go for roll bending. So large metal sheets and plates are formed into curved sheets using rolls. This is called roll bending. As you could see here in the photographs, rollers are used for forming operation. So roll forming, several rollers, this is a continuous roll forming process. Several rollers are used like a series connection, several rollers. So the forming process takes place in stages. There are three types: straight rolls, partial form, and final form. So initially the material will get compressed, the material will deform, and a series of rollers are connected. The final shape is decided by the final set of rollers. The next process is a spinning process. Metal spinning is a process in which a symmetrical part is produced. Like this is a symmetrical part which is produced when the part is gradually shaped over a rotating mandrel. This is a rotating mandrel using rounded tool or roller. So we can produce symmetrical parts like this using spinning process. Spinning process means we rotate the workpiece or disc, for example, disc shaped workpiece at a very high RPM. They can be done by hand or by connecting it with a conventional or CNC lathe machine, and then they are rotated with very high speed, and a tool is used for shaping the material at high speed. A tool like a roller or a similar tool is used. You can see the mechanism here. This is the disc shaped workpiece, and the roller shaped tool is used. When it presses against the mandrel, the material will get deformed. Plastic deformation takes place, and it will have a similar shape of the mandrel. So this process is called a spinning process. And you can see here, these are the other other parts which are produced by a spinning process. So it has applications, many applications to produce, like lamps, spheres, vases, solid wood furniture, and many other items. It also has alternate applications such as the production of metal sculpture or artistic and design purposes. For those purposes, we go for a metal spinning operation. Advanced metal spinning techniques like using CNC machines also are used nowadays. So symmetrical parts gradually shaped over a rotating mandrel using a rounded or roller tool. That is called metal spinning, and the speed will be very high, and the material and the metal workpiece is pressed against the mandrel to produce it. Now we come to high energy rate forming. It's another process which is not done on the presses. So in high energy rate forming, as the name indicates, very high energy for a very short duration of time. This process is called high energy rate forming. One of the example is explosive forming. So in explosive forming, what we have, a charge of explosive. When it explodes, what happens? It produces pressure waves or shock waves with very high velocity over the range of 120 meter per second. And these shock waves could be used to deform or for the forming operation. That's the advantage of high energy rate forming process. So here, as you could see here, the die cost is low, easy maintenance, possibility of forming most of the metals. Most of the metals can be formed. Material does not show any spring back effect. As we studied in bending, one of the problem associated with the sheet metal working or bending operation is spring back effect, which is absent in high energy rate forming. So they are successfully used to produce steel tubes from steel rods. Steel tubes can be produced. These are some of the, this is the application of a high energy rate forming, and let us see how it works. As I explained before, high energy for a very short period of time, an explosive charge will be there. So there it is filled, actually this is in water, and what happens is there is a die, and air is pumped from the die. It is under vacuum means very low pressure, so pressure from this side would be very less, and if the pressure from this side is less and the pressure on the upstream side and the top side is more, there will be a higher pressure difference which will allow the metal to bend. As you can see here, the workpiece is clamped just above the die. This is the die. This is the shape to be produced. So as the explosive forming, when the charge explodes, so high shock waves with high velocity, like over the range of 120 meter per second, are produced. These shock waves will create a pressure on the surface of the workpiece, and the metal bends, and sufficient deformation, plastic deformation takes place, and we get the desired shape of the product. So this is called an explosive forming. They are widely used to produce products in aircraft or aerospace industries, because the defectives or imperfections would be very less in such cases. Any kind of metal without removing material, we can change the shape. This is the advantage of explosive form material. So thank you very much for listening. Thank you.